today. We're going to talk about power functions and function operations. First thing we're actually going to talk about it in the other order. But function operations, all it is are, what are operations? Yeah, addition, subtraction, multiplication, division. They're all listed right there for you. Okay, so if I'm going to add two functions together, that's just collecting like terms. So if I want to add f of x and g of x, okay, that's just purely notation to say that we have two different functions. One we're calling f, one we're calling g. Okay, f of x in our example is going to be 2x, g of x is going to be x plus 1. If I take 2x plus x plus 1, collect your like terms. You get 3x plus 1. Subtraction works the same way. My advice to you on subtraction, distribute your negative and make it an addition problem, just like we've done before. Multiplication, if I take 2x times x plus 1, okay, they're going to symbolize it with this dot. You're just going to multiply them. You can either distribute, in this case, you'd take 2x times x to get 2x squared, and 2x times 1 to get that 2x. Otherwise, you can use your box, you can FOIL usually, something along those lines will work just fine. And then division. Most of the time, it's usually as easy as putting one on top of the other. And then look to cancel if you can. We are going to talk about the domain. If you guys remember back to the beginning of the year, the domain is all the x values that our graph can take on. So what I mean by that is if you think of a line, are there any x values that can't be on a line? No. No, because a line is going to stretch in, at least horizontally, it's going to stretch both ways for forever. So it would be not in a real plane, though. You'd have to graph that on a complex plane. So, and we will talk about I in a couple slides. Okay. So the domain of H, the function we get after we do one of our operations, is going to consist of the x values that are in the domains of both f and g. Additionally, the domain of a quotient, okay, division's quotient does not include x values that are going to make g, or this denominator, 0. So in my example here, what x value would make my denominator 0? -1. So we cannot have -1 in our domain. Then a power function is going to be a function in the form y is equal to ax to the b. Where a is a real number. Okay, so it can be whatever number I pick, as long as it's in the real number system. So this one would not include I. And b is a rational number. Remember, a rational number is anything that can be written as a fraction. So fractions and whole numbers, you guys can think of those as rational as well. Because if you think of like the number 4, you can write that as 4/1. What's going on? What's going on? This isn't that funny. You've been laughing for 5 minutes straight. So either fill us in with the joke, or, okay. Then we're going to let f of x be 2x to the 1/2 and g of x be negative 6x to the 1/2. The first thing that we want to do is we're going to find the sum of the functions. What does sum mean? Add. Okay? So that means h of x, and really you can pick any letter. Usually you're just going to pick h. I picked it because that's what they showed us in the last slide from your book. Okay? We're going to take f of x plus g of x. What is f of x? Two x to the 1/2, and g of x is negative 6x to the 1/2. Okay. I have the same exponent, which is good. Now you just add 2 and negative 6. You get negative 4x to the 1/2. So there's A. B, we're going to find the difference of the functions. What does difference mean? Good. So h of x is going to be f of x minus g of x. So instead of 2x to the 1/2 plus negative 6x to the 1/2, we're going to get 2x to the 1/2 minus negative 6x to the 1/2. Looks like I'm subtracting a negative, which is the same thing as adding a positive. Eight x to the 1/2 power. And the last thing that we're going to do, I'm going to talk about it on your assignment. You can try it if you want to, but I'm not gonna worry a ton about it just because domains are kind of weird, and there's only a few specific cases where knowing them are going to benefit you a lot. So, like I said, you can try them if you want, but they are going to, I'm not going to put a lot of stock in them. So, okay. Domain. Is there anything, and we want to try and stay in the real number system here. What does the 1/2 power mean?
Divide by.
So, close. Thank you, says.
Divide by half the number.
So, you're not going to divide. It means you're going to take the square root. Okay? Is there anything that I cannot take the square root of and stay in the real number system? Yeah. We can't take the square root of a negative number and stay in the real number system. So how we're going to say that is we're going to say that the domain is going to be any number we want except it has to be greater than or equal to 0. Okay? If I go below 0, now I'm taking the square root of a negative number. What about subtraction? What is my domain going to be there? So what does the 1/2 power mean? Square root. What can I not take the square root of and stay in the real number system? A negative. So our domain is going to be all reals that are greater than or equal to 0. What's that? So because I don't want to take, I can plug in any number in for x that I want, as long as it's not a negative number. That's all that's saying. So it wouldn't matter. Because what this is saying is take the square root of whatever you plug in for x and then multiply it by 8. So since you're doing the square root first, then it doesn't matter. Good. Okay, we are going to let f of x be 3x and g of x be x to the 1/4. We want to find first the product of the functions and b the quotient of the functions. And then we're going to find the domains of the product and quotient. So, A, the product. What does product mean? Multiply. We're going to take h of x is equal to f of x times g of x f of x is 3x times x to the 1/4 What do I do with my exponents? Since I'm multiplying, we're going to add them. Okay? We're going to get 3 to the x to the first plus 1/4. 3 to the 5/4. Oh, yeah. X to the 5/4. Thank you. Okay. B. We're going to find the quotient. What does quotient mean? We're going to divide. So h of x is f of x divided by g of x f of x is going to be 3x. G of x is going to be x to the 1/4. What am I going to do with my exponents now? We're going to subtract those. We're going to get 3 times x to the 1 minus 1/4, or 3x to the 3/4. Last thing we're going to do, talk about the domains of the product. What does 5/4 as an exponent mean? Really what I'm concerned with is the fourth part of it. So if I have an exponent, this 1/4, what does that mean? So if 1/2 was a square root, Yes. So a product or an exponent of 1/4 means that we are going to take the 4th root. So what can I not take the 4th root of? What's that? So you can still find them. They're not going to come out nicely, but you can do it. What kind of a number is 4? It is an even number. What else is an even number? 2. Okay, what can we not take the square root of? Negative numbers again. Okay, so even numbers are all going to behave the same. So our domain is going to be any real number we can think of as long as it's greater than or equal to 0. Okay. Now, because it's 3/4 instead of 5/4, not much is going to change. What can we not take the 4th root of? Negative numbers. So our domain is going to be all reals greater than or equal to 0. Just a tip, if you guys ever get asked domain like in a college class, your best guess, if you have absolutely no idea, is going to be all reals. So the even part, the 4s, is that what you're asking? Oh, because you can take odd roots of negative numbers, but you can't take even roots of negative numbers, because then you get into that complex system. All right. We're going to talk about the composition of a function. So, how this is going to look is you're going to have f, then a parenthesis, then a g, x in parentheses, and then the last parenthesis to close out the parenthesis with f. What all that's saying, okay, is you're going to take g of x, whatever function that is, and anywhere you see an x in f, you're going to put g of x in there. The domain, all x values, the x is in the domain of g, and g of x is in the domain of f. So basically what that's saying is you are going to have, you're just going to keep narrowing down your possibilities. We're going to let f of x be 3x to the negative 1, and g of x be 2x minus 1. For a, we want to find the composition of f of g of x. Actually, one way we may want to deal with this. What does x to the negative 1 mean? Not to the negative 1. That would be the square root of negative 1. Yeah, it's going to stay the same. All we're saying is that 3x to the negative 1 is going to be 3 over x. Okay. Where your letters occur are important in this. So, which one is the farthest inside?
F.
So, F or G? G is farther inside, okay? So, G is inside of F, which means we're going to take function G and put it inside whatever function F is. So, since F is 3 over x, okay? wherever there is an x, we're going to put 2x minus 1. So that's going to give us 3 all over 2x minus 1. Nope. So this is just saying you've got g evaluated at some number x. Whatever x is, what I could do is I could have you put in a number. So like g instead of x, I'd have a 2. What you could do is you could take g, plug in a 2 for x in here, actually get an answer. So like 3, and then plug that 3 in to f and actually get a whole number answer. Okay, B, we're going to find g of f of x. So, now which one is farther inside? F is farther inside, okay? So now we're going to take f and plug that into g, okay? So, g of f of x is going to be, we're going to copy down g just like we see it too, but when we get to this x, we're going to plug in a 3 over x minus 1. So it's a lot like substitution, except instead of lines and things. So from back here, because it's 2x minus 1. So this is the 2. Here's your x minus 1. Good question. Okay. Multiply that out, you get 6 over x minus 1. C, f of x. F is going to be on the inside and the outside, okay? What this is saying is we're going to plug a function into itself. So, f of x. Oh, I'm sorry. Okay? I'm actually going to use 3x to the negative 1 instead of the 3 over x. It's going to make things a little cleaner for us. Otherwise, we're going to get in compound fractions, which people don't seem to like. Okay? We're going to have 3. Okay? It's going to be x, which is 3x to the negative 1 to the negative 1. Okay, just a reminder, we're using f of x is equal to 3x to the negative 1. Now, because I've got multiplication raised to an exponent, distribute that. So I get 3 to the negative 1, which is 1/3. 3 times 1/3. And x to the negative 1 to the negative 1. What am I going to do with those negative 1s? Yeah, we're going to multiply them to get x, or x to the first, same thing. What's 3 times 1/3 x? Yeah, it's just x. Yes. Okay. And that will happen when you plug a function into itself. You should get x out.
So what first f, what do you plug in for first f?
This one,
3x minus 1.
3x minus 1 is going to go inside 3x minus 1. So
So there's like 3 things in that first.
this one,
Yeah.
this x, this is just saying the f of x, okay? So we're treating this thing as one piece.
So basically f and f of x are the same thing?
Yes. So this x really just serves as a placeholder if you were to put a number in there. It tells you what variable you're working with most of the time. Okay, the last thing, we need to find the domain of all of these. Okay, when I have a fraction, what you want to look for is square roots and denominators of 0. So, do I have any square roots going on in A? No. How could I find where my denominator would be equal to 0? So, to find where this denominator is going to be equal to 0, I just set it equal to 0 and solve for x. Add 1. I get that 2x is equal to 1. Divide by 2. X is equal to 1/2. Okay? So that, if I plug in 1/2 for x, my denominator is 0. Okay? You can't divide by 0. So our domain ends up being any number we want, except x cannot equal 0. Or not 0, 1/2. G, I have 6 over x minus 1. Do I have any roots that I need to worry about? No. Okay. What number would make my denominator 0? Yeah, so our domain is going to be any number we want, all reals, except x cannot equal 0. This last one, okay? We've got to look at our original function as well. 3x to the negative 1 or 3 over x. What can x not equal? 0. Our domain is going to be all reals. X cannot equal 0. Questions on that? All right. There's your assignment. We'll check that tomorrow.